I'm really glad to present this 11th program from our side, Maitreji. And this time it's very special. The reason being our association with the Global Association for Corporate Services. We have Jatin, we have Samir, who is General Secretary of GSES. Incidentally, I'm also part of GSS. So thank you so much, Samir, for accepting a proposal for supporting this particular event. And we are presenting this together, that is Maitreji Mumbai plus GSES under the School of Excellence program. This is actually second talk on this subject, but as part of New Era Career Guidance Series in association with GSS, this will be first. We will definitely repeat the first one depending on the speaker's availability. We have Parag Mahazani. I'm going to introduce him separately. Before that, as per our tradition, I request my dear friend Atul Kinikar to start this event with a prayer to God. Before that, I just quickly go through some of the specific things for you. I'm sure that you all will be following necessary lockdown procedures and will be doing great. Thank you very much for joining this conversation. We hope you will find the same useful. Please keep your microphone mute, and you may please switch off your camera for better reception. This will not disturb others also. Please feel free to ask your questions using the chat option. We will discuss the same with Parag after his talk at the end. We will try to accommodate maximum questions. In case you have any specific questions which you would like to take offline, Parag is going to share his email address with you, and you can definitely get in touch with him. The session will run from 5 p.m. to 6:30. In case it gets disturbed or interrupted in between due to any technical reason, please join the meeting again. So with this, I hand over this call to my dear friend Atul Kinikar. Atul, you may please start.
Yeah, thank you, Avasai, and thank you, JCS for supporting this event. Now we'll start with Poseidon. आता विश्वात्मके देवे येणे वाग्यज्ञे तोषावे तोषोनी मज द्यावे पसायदान हे जे खळांची व्यंकटी सांडो तया सत्कर्मी रती वाढो भूता परस्परे पडो मैत्र जीवांचे दुरितांचे तिमिर जाओ विश्व स्वधर्म सूर्ये पाहो जो जे वांशील तो ते लाओ प्राणी जात वर्षत सकळ मंगळी ईश्वर निष्ठांची मांदियाळी अनवरत भूमंडळी भेट तू भूता चला कल्पतरूंचे आरव चेतना चिंतामणीचे गाव बोलते जे अर्णव पियुषाचे चंद्रमे जे अलांछना मार्तंड जे तापहीन ते सर्वाही सदा सज्जन सोय रे ओ. किंबहुना सर्व सुखी पूर्ण होनी तिन्ही लोकी भजिजो आदि पुरुखी अखंडित आणि ग्रंथोपजीविये विशेषी लोकीये दृष्टादुष्ट विजये ओ आवेजी. येथ म्हणे श्री विश्वेश्वराओ हा होईल दान पसाओ. येणे बरे ज्ञान देओ सुखिया झाला सुखिया झाला सुखिया झाला. धन्यवाद. Thank you very much.
Yeah. Thank you, Atul, for that wonderful prayer.
Thank you.
I have Mr. Samir Saxena, who is General Secretary of Global Association for Corporate Services. I would request Samir to take a minute and just share his experience, opinion, and special comments. Over to you, Samir.
Thank you, Mr. Abba Sahib. It's a pleasure. It's a pleasure and an honor for all of us at GACS to be a part of this amazing platform. When Abba Sahib spoke to me about this, I was pretty excited to hear about it, and I think the kind of thought process which is going behind creating this movement, behind creating this noble cause is phenomenal. And thank you, all of you, for thinking about it, trying to take it ahead, and reaching out to the larger world. I'm delighted as GACS to be a part of it, and you have our commitment that we will always be supporting such a beautiful initiative moving ahead. I'm extremely I'm extremely keen to be a part of today's session and have my learnings out of it. So I won't hold you between the session. So thank you very much, Abba Sahib, for giving us this opportunity, and all of you. We at GACS. So GACS is a small organization. When I say small, in terms of the kind of reach that we have is across Pan India. As we speak right now, we have multiple other international chapters coming up, and we are only approximately 5,000 members strong organization. We have presence in 11 states in the country, and we are the industry voice for all the people who are working in the corporate services domain. That's the only small introduction about GACS, and I won't hold you further. I'm Abba Sahib, back to you, and thank you once again.
Yeah, thank you, Samir, for that encouraging support. I now take only 2 minutes to introduce our today's speaker. I met Parag a couple of months back. I think it was month of February when I had gone to attend one very interesting event on astronomy by very well-known institute organization in Vilepal in Mumbai, Jana Seva Samiti. And I could not resist myself to introduce to him after his speech of around 2.5 hours. I think I remember it was on various moon expeditions till date, and he spoke uninterruptedly for more than 2.5 hours. It was pin drop silence in Satya College, And believe me, it was a great experience. I think more than that, uh, I was at this age, I was attracted toward this subject. And that's where I decided to look into this opportunity to invite him for this particular session. In fact, we thought of inviting him at our Mumbai venue, which we normally do at Savarkar Udyan in Mumbai, in Borivali. I think before I start, I would like to mention few things about him. Pardon me, because this is to be. I please request participants not to use screen because it is really causing problem. You please don't use your hands on screen, so that I do repeatedly. Please mute your mics. Pradnya, can you please mute your mic? Yeah, sorry for this disturbance. So right now, I think in the month of November 2019, Parag discovered few asteroids using NASA telescope at Hawaii. At the moment, he's working with NASA on Pan-STARRS project. He had great honor, and he was very lucky to work with Professor Mohan Rao Apte, who is supposed to be Urdu of this particular subject. And I think he is associated with Jal Seva Samiti from 1988 at the age where he was doing his diploma. And I think I have specially requested Parag to cover that subject to for the benefit of entire society here. What exactly was very helpful during that particular age. Astronomy and astrophysics is probably one of the most interesting fields to pursue as a hobby or as a career, but very few people knew about the intricacies in this area, and Parag is one of them. He's a well-known public speaker and author in the field of space science and technology. Currently, he's owner of science and technology outreach organization called Milky Way Citizens. This organization is active in many countries as a consultancy organization to large corporates, hospitality industry, and public domains. He loves to conduct astronomy programs, observations, and lectures for the guests in resorts for more than 15 years. In fact, he pioneered the concept of astronomical observations for public in 5-star resorts in Maldives, Thailand, India, Oman, and Vietnam. He has delivered more than 1,500 speeches in Asia, Europe, and South America in the last 32 years, and students and public at large. He completed Diploma in Industrial Electronics in 1989. He is rank holder of University of Mumbai, Bachelor of Engineering, Department in Electronics and Telecommunications. He was there, he passed out around year 1992. He completed his post-graduation in Business Management from NMIMS in 1995. And he's associate member of Institute of Engineers, MIE. He was selected as Fellow of Royal Astronomical Society, London, which is one of the most prestigious fellowship in the world offered in the world, and the Royal Society of UK offered this fellowship in year 2006. Yes, 2006. Going ahead, he has received various awards. He is a state level Best Literature Award winner, C.D. Deshmukh Puraskar for Science and Technology category for his book Taryancha Vishwat from Maharashtra government, and he is the youngest recipient of this award. He is author of best-selling book on astronomy, and as well as he has published more than 200 articles in various newspapers in India and abroad on subject of science and technology. He had led Indian astronomy team 4 times in International Astronomy Olympiads held in Italy, Crimea, Ukraine, and Russia. He's been appointed as consulting wireless engineer. This is very interesting, at various levels by few multinationals like Philips India Limited and British Telecom Limited. Parag, we will definitely, from GSS side, we will definitely like to connect with you on this particular aspect as part of School of Excellence. We spoke about that yesterday. And he's a senior faculty at Birla Institute of Technology, BITS, for satellite telecom engineering courses. I think it was really my honor to read this biography. And once again, Parag, thank you very much indeed for coming here and sharing your valuable time with all our participants. Now I hand over this entire forum to you. And in case you need any help, please feel free to reach out to me or Prashant or Atul or Jatin is there during entire course of discussion. And as I explained, we will take the questions for the session on chat on chat section. Please type your questions on chat option available. Prashant and myself, we will look into those questions, and at the end, around 6:10, we will once Parag closes his presentation, we'll start taking those questions. Over to you, Parag.
Thank you, Abhijit. Thank you very much. Thank you very much, everyone, for joining this session and inviting me here in this forum. I would just like to request Abhijit, if you can share because I can share the presentation maybe within the next couple of minutes time.
Yeah, you can share.
Yeah, thank you very much. But before that, as you asked me that I should talk something about how I started this, we had a call in the afternoon, and so I'll just talk maybe a couple of minutes, and then we'll actually go into the topic. Am I audible to everyone? Is it fine? Is it okay?
Yeah, you are.
Yes, yes.
Okay. Thanks. So this was basically when I was approximately 16 years of age. It was in '86, and there was a Halley's comet which was visible at that time in the sky. And I was very new because I was just in 9th, 10th standard. My dad asked me, should we go and watch the comet? I said, yes, of course, but what's a comet? And then he said, okay, let us talk about it. And we went by train to Bombay Central, and then took a bus. It was night, something like 10:30. And when we were out, just outside the planetarium, I realized that there was a queue of something like 1,000 people with the telescopes inside. And I asked my dad that, I don't think we will be able to see the comet. It's too much. I mean, we have to wait for the queue for the whole night. And he said, yes, let us wait. And then we were talking, we were chatting, the whole night we were in the queue. And he was talking a lot about various things, but I don't remember at the moment what we discussed. It's a long time. But I was quite awake. And then I remember we had a tea at 2 o'clock in the midnight, and we were just in the queue. And when our turn came, it was something like 5:30, 6 o'clock in the morning. It was already, the sun was out. And so I couldn't see the comet. And so that was, I was in tears. So he said, but don't cry. I said, I knew, because he told me only that time, that this was the last apparition. I mean, we will not be able to see it next week or something. So I said that we have missed the comet. We will not see it. Never, ever, now. So he said, don't worry, don't cry. We will make our own telescope, so we don't have to depend on anyone. And that was a kind of a trigger. And I said, oh yes, of course. That was quite an exciting thing, because there were no computers, there were no color televisions, no mobile phones, nothing, And that was quite interesting. And then we made the telescope. It took a couple of years to make the telescope, which was a proper professional telescope. That time we were knowing nothing about it. So we went to various shops in Churchgate. We contacted various people in Delhi to get the lenses, and we are not knowing about it. But ultimately we made it. And then when the time came to actually see the moon, then I realized I do not have an eyepiece. Eyepiece is eyepiece. Eyepiece is at what your eye level it fits in. So someone told me there is someone called Professor Mohan Apte, and you can meet him, because he keeps such kind of gadgets. And then I went to him. I went to Professor Apte. That was my first meeting with him. It was something like 87, 88. And then that was the beginning of all the different kind of learning. Professor Apte was amazing, amazing person. I'm really, really lucky that I met him. And I spent something like 3 decades with him, learning variety of things. Meeting many people, writing research papers, publishing the papers, giving talks, conducting workshops, variety of things. And he taught us something which I cannot explain in a couple of minutes time, of course, but that is what he was. But he always told me, and he always told all the people, I mean, we were 5 or 6 people when we started the organization, Janaseva Samiti, what Abhijit was mentioning about. And so he was telling everyone that don't do your don't continue in job for long. And we were very young, you know. I just started my diploma, and then it was long way, degree and masters and all. He said that you just do it for some time, and then you do something so that you will create your own name and reputation. And more than that, you will create a kind of a footprint for the people who are lost in the jungle of life. And there is a nice poem which I will share later on. I didn't find it at the moment. I have kept it somewhere in my library. But that poem was written basically. It was translated by Shantaram Athole, and very beautiful poem. And so that was the point, you know, which he wanted to inculcate in the youngsters. So the point is, when a young person, man, boy or woman, girl, at between the age of say 17 to 20, if he or she finds the right person, you know, it changes his complete life. And I experienced it in myself. I experienced it in a couple of people who are now doing variety of things in different spheres of life, some in history, some in engineering. So that was something which I wanted to share, as Abhijit was asking me. Going back to today's topic is, yes, I'm doing astronomy for since when I was 16. Now I'm around 50. And believe me, half of my brain, which is behind the back part of the brain, is all the time thinking about stars. I don't know, I can't stop it. It is 24 hours thinking about stars. The front lobe is always talking about something else, but the back lobe is always about stars. I don't know why. And so continuously, I just think about stars and nothing more. I can't escape from it. That is something what is my condition today. So this talk is basically this talk is for parents as well as for students, boys and girls who are above 15, you know, and just to inform them, especially this is for parents as well, to talk about, you know, what astronomy is and what we can do about it. So let me share the screen. I hope you can see it. And this is a small talk. So let us begin straight away. So astronomy, when we talk about astronomy, then there are a variety of things which come in our mind. And most of the times they are about stars. Okay. So how we should go about, you know, doing astronomy? That is something something is the topic today. Most of the times we do astronomy in a sense, we go to planetarium, we do some attend some planetarium shows, and that's it, you know. But there is quite a lot of things involved in that field. So let me just give me a second. Be sharing this screen.
Parag, any problem?
No. I'm just again so that let me start with. Yeah, can you see the screen now? Okay, fantastic. So now this is basically, I just mentioned here astronomy for amateurs, but this doesn't mean that it cannot be done professionally. This amateurs means basically the boys and girls who are between the age of 15 and above, 15 to 20. So there are a variety of things one can do. So there are, say, optical astronomy, which we generally are familiar with. Okay, another one is computer astronomy, and third is radio. Now, radio astronomy is not only related to radio. I just wanted to say it is called multi-wavelength astronomy. Now, astronomy is study of stars. Now, it is study of stars. It can be the study of planets. It can be study of galaxies. You know, basically, it is nothing but the study of matter in the universe and the space. Okay, so the interaction of matter and space is all the time. Now, there are a variety of things which are there in space, and most of them are invisible in a way to the human eyes or even to the telescopes. So the telescopes are of different types. One is something like optical, which we are used to. We see the binoculars, we see the birds on the trees, or we see stars. Or we have telescopes, but that is an optical part. So there are variety of things in telescopes, like radio telescopes. They can see only radio waves. Infrared, they can see only infrared waves. Cosmic, they can see only cosmic rays. Okay, so the variety of ultraviolet, there are variety of X-rays, there are variety of, basically it's a spectrum. And one can see the entire universe into this spectrum. And each spectrum is like a lifelong study. So this is called as a multi-wavelength astronomy. So when I was talking about this radio, this means that it is basically multi-wavelength astronomy. Now, as we go along, most of the times the astronomy, which is simple in a sense, is optical astronomy. That's what we feel, because we we see, we know how it is, and we can perceive it with our eyes. So X-rays, if I tell you, you will not know what it is because you cannot see anything. Similarly for radio, similarly for microwaves, and all the different kinds of topics. So this is something quite a new, and for youngsters, basically I wanted to say that this is a known area. Okay, and this needs to be explored quite a lot. I mean, very few people know about it. And another thing is, very few people are equipped for such kind of a work. Luckily, in India, we have quite a lot of things happening in this field. Let us see, as we proceed. Now, any of these fields, if you take, now computer astronomy is another big subject of research, and these people never look in the sky. Okay, so they always look on the computer, and it was quite an interesting event. It was a solar eclipse, and I was watching this. I decided to go to Varanasi for this solar eclipse 2009, and some of my colleagues from IIT Bombay and a variety of people, Bits Pilani and Banaras Vishwa Hindu University. So they also wanted to join. So I met a couple of astronomers in TIFR, as I was associated with TIFR for a long time. And they said, oh yes, there's an eclipse. I said, yes, but you are not going to witness it because this is the last in India in our lifetime. And they said, no, we are doing it on the computer. We will just look down, not up. And so I feel very pity for them, very senior scientists. But this is what happens. Most of the astronomers or most of the scientists nowadays, they just focus on the computer. Okay, but there are a lot of things to do on computers, especially computations. So computer astronomy is another very interesting field which is getting developed very fast, and very many people are working on. Now, either of these things one can do, or maybe some people are doing multiple things, but they can contribute either to education or they can contribute to research. Okay, so contribution to science means research, and contribution to education means popularization or communication. So these are basically very different disciplines, and one needs to have very different skills in this. So most of the astronomers or most of the scientists which I have met till date are really good in research. Okay, so they spend their whole time in the labs or in the observatories, taking observations of the stars or the planets with massive telescopes, and taking the data, analyzing the data, communicating, everything. Okay, but if you ask them to give a talk in front of students, for example, it becomes a real challenge for them. And they most of the times they listen because this is very difficult. It's a very different angle. On the contrary, I have seen many people who are not research scientists, but they can talk very well. They are really good teachers. And so these are very different ways of looking at it. So all the youngsters or the parents who want their child to develop this kind of a very specialized subject, they have to check what are they made up of. Either they are towards education, they can teach well, they can explain the concept, they can talk, they can imagine, visualize when they're talking, or they're very good in research. So they can find out new things. They're very good in data mining, or variety of data analysis, large data using programming languages, and a variety of things, mathematical functions. So this is to find a person who has both the skills is very difficult. I have found few. One of them was Professor Jayant Narwekar, of course. Then another one, I have not met him, but I have listened his lectures 100 times, who is Richard Feynman, who is no more. There are a variety of other people in TIFR, in Indian Institute of Astrophysics, or in NASA. So they are basically, they have a blend of both, but it is a very rare thing. So the children or the boys or girls who wanted to enter into this area, this is the first and the foremost observation they have to make on themselves, that whether they can teach well, whether they can explain it well, and whether they love teaching, that's one, and or they are good in research. Either or is fine. If there are two, you have a jackpot. But if you have one, it is absolutely okay. Okay, so this is something, the first and foremost. So these are two different things completely. And let me just point these two. Okay, so going front. Now let us see in the popularization. I mean, this is basically education, and this is a huge domain. Now you know that there are many people who have done their PhDs in education, okay, and further studies, okay. So in education, there are a variety of things one can explain. Now at the moment, I'm explaining you with without any material. I just have some slides in front of you so that you will get some link, but I don't have a model. Generally, I carry my models, which are actually three-dimensional models, and I can operate those models in front of you. Okay, I do it in my program, in my talks, which we call as Universe Mysteries, and that is on Tuesday. Every week I give one free talk, which is on Zoom, and you can join. You are most welcome to join. Your friends, your colleagues, your students, children, everyone can join. So I try to explain with some of the models, but every time it's not possible. Okay, but this is one of the great skills one can have. We don't have a single model maker. Believe me, in India, we have such how many 125 million people, 1.25 billion people, but we don't have model makers in astronomy. We want good model makers in astronomy, and there is a tremendous scope in this area, but no one is there, absolutely zero. Okay, so this is something very crucial for education. Now, popularization or communication is not only talks. It can be a variety of things. We will explain. Research is direct research. Now, research is a field where you enter into a particular domain. Say for example, there are certain stars in the sky who are binary. That means that two stars rotate around each other around a common center. We call a barycenter. Say for example, let us take the planets Earth and Moon. Now, the Moon, we believe and we think that the Moon rotates around Earth, okay? But this is a perspective. It is not the truth, okay? So the truth is that which reference frame you're talking about. Are you talking about you're standing on the surface of the Earth? Then it is tropocentric. That's fantastic. Then you think that, or you see that the Moon is moving around you, the Sun is moving around you, but that is not the real thing. If you watch from the Sun, you see that Moon has not completed even single round. Listen carefully. If you look from the Sun, and you see that the Moon has not completed even a single round around the Earth, because your reference frame has changed. Okay, so these are some of the perspectives, and it makes it extremely interesting. This subject of astrophysics or astronomy, it becomes so interesting because you change your reference frame and you have a complete different view of the universe. Okay, so you take a particular subject of say binary stars. So I was talking about say planets like Earth and Moon. So the barycenter is below the surface of the Earth, something like 1700 kilometers. So Moon is not moving around us. Moon is moving around the barycenter, which is below the surface of the Earth, 1700 kilometers. And so these are the two bodies which move around each other. There are many stars in the galaxy. Okay, so we have something like 200 billion stars. It means that there are more stars in the galaxy than the entire the sand particles on the entire eastern coast of India. Okay, I'm just talking about one galaxy. I am not talking about 100 million galaxies we know. Okay, so it's a massive subject, and we don't know much about it. We think we know a lot, but if you ask a real astronomer, he will answer that we don't know even 0.1% till today. Okay, so most of the things are unknown to us. So these binary stars, then you focus on the binary stars, how they rotate, why they rotate, then what are the magnetic fields, what are the gravitational interactions happening among, how the gas from one star flows into another, and then how it affects as an accretion disk. Sometimes one of the stars is a black hole, and one of the stars is a normal star like the sun. First topic, which is popularization. See, there are a variety of things people can do. Believe me, everyone cannot be an astronomer, okay? Because the reason is very simple. As you start in astronomy, it's fascinating, and it is fascinating. There is no doubt about it. But as you proceed, you do your 12th, you have to do physics, chemistry, mathematics, biology. You have to take entire thing in 12th standard, okay? So you should not skip anything for something like scooter mechanic or something electronic because you get good marks. That is nonsense, okay? So those I'm talking about for the students who are there in 11th and 12th. Please, if you wanted to pursue such kind of disciplines, which are hardcore disciplines and very strong in foundations, you have to take physics, chemistry, mathematics, biology in your 12th without fail, okay? And why biology? I will explain later. As you proceed, as you take BSc physics or you go to engineering, doesn't matter. You can be BE or BTech, then you ME or MTech, and then you can enter directly into astrophysics. Okay, that is also a route. Even after Bachelor of Engineering, you can enter into astrophysics. Or you can enter from MSc physics or mathematics or chemistry or biology. Biology also, okay? So you enter into astronomy, in the domain of astronomy, and then you do a master's and PhD or postdoctorate later on, and then you become a real scientist, actual scientist who is actually working on the real data coming from the space telescopes or coming from NASA telescopes, a variety of things, coming from basically supercomputers in a variety of things. So this is the real work. But many people in my life, that many students go up to MSc or MS and stop. Okay, PhD becomes too tough. Because of variety of reasons. You need to really love the subject, okay? So if you really love the subject, like say mathematics or geometry or chemistry, okay, organic chemistry, doesn't matter, or biology, okay, so microbiology, okay, so you should really, because what happens is in the PhD, it becomes really tough because people are spending a lot of money on you, and then they expect research papers from you. Later on, you have to be a full-time scientist, and the job is to publish papers, at least 4 to 8 papers a year, depending upon the university. If you're in a big university in Cornell or in MIT or in Harvard or or even in TIFR, then you have really strong pressure that you have to publish something new every time, okay, and that of high quality in international reputed refereed journals. So many times people falter there because it is too much pressure. Discovery, I'm not talking about discovery, okay? Abhijit, we should talk about discovery sometime later, because that is another big subject of interest, because I'm in the field of discovery and I personally discover things. So it is another pressure. It is another time pressure. It is another technical pressure on you, that how you take it and how you discover it. Discover means you do it first time in considering 8 billion people on this planet. So whatever you see, you are the first among the 8 billion people. And that's not easy. That's not easy, because there are people who are watching through different telescopes, variety of things happening. Okay, so that is a quite tough challenge to take, but you can take that. Some people can take that. The point is, you have to decide where you fit in. Do not just jump in. Okay, so let me continue with this. Now, this popularization is also another interesting stuff. You can do talks, you can give slideshows, you can do model making, but a variety of workshops. You can conduct exhibitions, writing articles, writing books, and guiding students. I will give an example of exhibitions just in a couple of minutes time. When I'm from Vileparle, and so I was in the funnel zone. Okay, my house, still I have a house in the funnel zone. So all the time the aircrafts go above us and they land. So they are very close to us, something like not even half a kilometer. And it was quite a nightmare for many people in my home, because you cannot take a nap in the afternoon. You cannot talk much, because every 5 minutes or 4 minutes, you will get a jumbo jet above your head. Okay, so I'm grown up in that area, but I used to love aerospace. So I started writing to them, to various airlines. That time there was no internet. I'm talking about 87, 88. And then I started writing to the airlines like Singapore Airlines or Thai Airways or Pan Am. That time there was Pan American. Now it's closed. British Airways and variety of things. There was a Concorde which landed in Mumbai, and I watched it actually. So that was quite an interest, and they used to send me all the entire data of that particular aircraft. So whether it is a Boeing 747, which was my favorite and still my favorite. So, or you have Airbus A337, whatever, you know, a variety of things. And then I used to study that. Then that interest got into space. And my dad was working in UC's library. So he was a librarian. And so he used to get Span, National Geographic, Life, Reader's Digest, variety of American magazines. So I grew up reading those magazines when I was 10, about 10, I mean. And so I started writing to NASA straight away. I remember I have my letter when I was in 9th standard. I wrote to NASA Jet Propulsion Laboratory in Pasadena, in California, asking that you have sent Voyager 1 and 2. Can you send me the photographs I want to study? And similarly, I wrote to ISRO, I remember. But unfortunately, for some reason, ISRO people are very busy. They never responded to me. But that's okay. I mean, they're very busy people. But NASA responded to me immediately. And they used to send me these parcels, this huge, that time there was nothing. Imagine we used to have these cradle phones, you know, ring, ring, hello, you know, that kind of phones. And PSTN we used to call, you know, public switch telephone networks. And then I used to have these massive packets which were full of slides and full of photographs, and I used to go mad. I did this for something like 10 years. And then I had so much of data with me that I have 2 Godrej cupboards full of only astrospace photographs. And then I started exhibiting them. I did 8 exhibitions on my own expenses. But it was a huge response. I was very young. I was 24, I think, just passed out my engineering and management, I think. And from NMIMS, no, before NMIMS, that was just after engineering. And tremendous response. Mumbai University, Bhavans College, you know, Hilton College, variety of places. Rajabai Tower, I just put the exhibition entirely inside Rajabai Tower that time. So there was a lot of you know, stir about among people, that many hundreds and thousands of people visited. So this is a kind of a thing you can think of doing if you're not perfect for research. Okay, model making needs a very different kind of imagination. Okay, but that is something you can think of. If you have any questions, you can write to me later on, and I can definitely go into details. Writing articles, I wrote more than 200 articles. I started writing in 1992 in Maharashtra Times, Maifal, and then I went on writing, you know, like crazy, like so many articles. I will share some of them with you if you are interested later on. And still I'm writing. So this is another interesting area. Writing the books, I got this Sahitya Puraskar, our, you know, Maharashtra Sahitya Puraskar. साहित्य संमेलनामध्ये तो पुरस्कार मिळाला मला 2006चा, and that was the C.D. Deshmukh Puraskar, which was the highest honor one can get in science and technology. And I was very lucky. I was very young that time. I was how old I was? I was 35, so I was the youngest recipient. So these kind of things happen to you as well. Okay. So, and guiding students takes a long time. So guiding students is another interesting stuff. I got involved into Astronomy Olympics, and then I led the team of our country 4 times because of, see what happens is you get a really interesting and very, very technically strong crowd, you know. So out of something like 2 lakh students, we used to select 40 ultimately at Nehru Center, Mumbai. And in May, we used to have a camp for 1 month. And I used to go to the camp for 1 month. I used to take off. I used to work for Mahindra British Telecommunications as a wireless specialist, space communications, satellite communication specialist. And basically a trainer as well. Of course on projects, but that was my main job. And so I used to get off completely. Okay. And then I used to go there and teach them, because that was the cream, the best cream of India. And today I can say proudly that some of my students are working in MIT US, in Cornell. They are professors in Cornell now. So that is because they were so bright, and to work with them, you have to be on your toes. You have to be on fire. Okay, because those kids are so bright at the age of between 16 and 19, and they will ask you questions and kill you. Okay, so many people actually ran away. And so this is, you have to have that passion to teach them, because they will ask you any damn question. Okay, and believe me, it is a nightmare for them and for us. We never allowed them to sleep. Even weeks and weeks they never slept. We were just giving them problems night and day. We used to be at GMRT in NCR, National Center for Radio Astrophysics in Pune, or we used to be at Nehru Center, wherever, or TIFR. Everything was open for us. ISRO, wherever we. So this was, and then out of those faculty members, so starting from Professor Narayakar, the senior one, to me, the junior, most junior one, everyone was there. And then out of these, two faculty members were selected by the participants. Okay, so you have to be really on your toes if you want to be the best. Okay, so I was selected 4 times as the best faculty in all, and then I was leading the team of India for international. And then once I got an opportunity to become a jury of the world for entire Olympics in Italy. So these are the things which happen. Why I am saying this, the reason I just wanted to, if someone gets inspired, that is it. That's I have done. Okay, so you can do it. You can do it if you really have that kind of a passion to teach. Okay, so this is something which you can go to that level. You can go to any level. Okay, believe me, it is an amazing experience to talk in front of the world. Okay, everyone is watching. All 34 countries were there in the Olympics. They were watching, and you are talking and giving a talk in front of the huge audience in Russia. We beat Russia in Russia. Okay, we stood first in the world. India team stood first in the world 2002 Olympics. So this is something which is quite, it feels really, really honored to be under the Indian flag. It hosted above your head, and then you're just saluting, and Jana Gana Mana is played in Russia. Okay, it's an amazing experience. So these kinds of experience you can get. I'm just talking about, I'm talking to all the youngsters here. Okay, so there are every domain here. Sky observation is a domain. Okay, I remember I have given talks when I was very young, something like, half of my age. So something like, say, 25, 26, or maybe, up to 30, 35. I have given talks for 6 hours continuously in the night. So we used to start by something like 11 o'clock in the night, and I used to finish by 5 o'clock in the morning. Stargazing sessions open for TIFR mathematicians or any people. I remember there were 200 mathematicians at one go. It was a TIFR event, and I was the only speaker. I was talking for 6 hours. Okay, just a tea for maybe 5 minutes. So these kinds of things can happen to you, and amazing experience you can get. This is a kind of enriching thing. Okay, so every topic is so close to me here. I don't want it to continue, because then I will never be able to finish it. Okay, in research, we have observations and data reduction. See, observations and data reduction. Richard Feynman has said that you might be the most smart person in the world, or you might have the most amazing idea in the world, or you have created such a fantastic, fabulous theory in the world, but unless it is tested experimentally or observationally, you are a fool. These are the words of Richard Feynman, the Nobel laureate. He is no more. So that is why in astrophysics, or in astronomy, or in astrobiology, or in astrochemistry, okay, or in astrophysics, or in cosmology, okay, so observations are very critical. And it is not just looking through the telescope, my friends. There are a lot of things involved. Years and years and decades are gone. You have to specialize into that area, because you are all the time with instruments, massive instruments. If you see the real observatory telescope, you will go crazy. What's this? For a few thousand wires going here and there, and so many cameras working at the same time, multiple computers, sometimes supercomputers, optical fiber networks. It is just a kind of unbelievable James Bond movie. And then you have to work in that, and you have to take that data, you have to process it, you have to do variety of image processing, then you have to come out with data mining, large data, you use Python, or you use whatever you want, C++, whatever it is, and then you come out with something which no one knows. Believe me, it is amazingly challenging and it is so interesting. So these experiences, if I go on talking, we will not end it. Okay, so I will not go into that domain again. I'm just saying that observations is a very critical. Observational astronomy is a very specialized topic. LIGO, where they discovered recently the gravitational waves, is observational. Here, it's an observational topic. They actually discovered it. Okay, particle physics, they're doing observational. So they have the Large Hadron Collider, which is $2.6 billion project in Switzerland. Okay, so these are massive projects. At the moment, I'm working on Pan-STARRS, which is 1.8. I'm working on the largest CCD camera of the world. Okay, so my camera, the diameter of my CCD camera is 1.6 meters. CCD camera I'm talking. Okay, so these are, so I can watch, see what I'm watching. So I'm watching, see what with our eyes. Suppose we see a particular star or a galaxy with our eyes. Okay, so if I wanted to see fainter and deeper, I use larger and larger telescopes. Okay, so at the moment, with the telescope on which I am working and discovering asteroids, the intensity, the faintness of the stars is 1 billion times than the eyes can see. So I can see the stars intensity or brightness, which is 1 billion times lesser than what we see with our eyes. This is unbelievable because of the technology. This is possible. And I'm doing it sitting in my studio here in Pune, or wherever I'm in. Suppose I'm in Vietnam, or suppose I'm in Europe or United States, wherever I go, I can do it on the airport, because my research never stops. So this is something you can inculcate. The point I'm telling my story is so that you can get some hints that this is possible to do. Okay. So data related observation, there is a huge, it's a big field of work. Data reduction is another big field of work. And these are the special areas, you know, where we need to have, we have to have some sessions. I'm planning to have some proper sessions on these, courses on this. You can register to these courses. And then, because this is the subject of something like 12 sessions or 24 sessions. Okay, so observations, you can have variety of topics. You can take comets, you can take eclipses, you can take planets, you can take the sun, the star, you can take meteors, you can take asteroids or the transits. You can have variable stars, binary stars, nova patrol, supernova discoveries, deep sky observations, or even ancient astronomy. So these are some of the topics, you know, these are the domains in which you can work for your whole life as a research scientist or as a speaker. Okay, so it's up to you what you select. Now, comet is a massive subject. Asteroid is a huge subject of work. And so these are some of the areas. I'm not even scratching the surface. I apologize. If you ask me to explain you and to give you a flavor of entire classical music, suppose I can play flute. I play flute, but not for public, I play for myself. But suppose I'm playing my flute and you ask me that, okay, you give me a complete understanding of classical music in 1 hour, it is impossible. So same thing is happening here at the moment. Okay, so I'm just introducing to you to different aspects of classical music. There are some ragas, there are some thumris, there are some tal, there are some lay, and what exactly they are in a brief. Okay, so this is something which is quite these are variety of, I'm just mentioning a few because the slide will get full, you know. Okay, so in data reduction, we have observations from spacecraft. Now we have repositories. You know, there are people who are doing only repository science. So there is few petabytes of data gets downloaded every night and it is free. Did you listen carefully? I'm talking about data which is A1 scientific data which is downloaded on the planet every night, a few petabytes. Who is going to analyze it? You. Okay, so there is a tremendous scope in data analysis. Now, data analysis or image processing, these are some of the amazing areas. Now there is an area called big data. Okay, if you go to MIT OCW, Massachusetts Institute of Technology, Open Courseware, you will find a course on big data. Take that. Okay, it's I think 24 sessions or 32 sessions. And then big data with Python. So you will get a basic idea what I'm talking about. Okay, so there are multiple observatories in space. There are multiple observatories on the mountains, and there are multiple observatories under the ground. Did you listen? Under the ground, even in Chandra. And because neutrino observations, how we can do the neutrino observations? Neutrinos are the fine particles. I will answer the questions later on. Okay, so you just go on covering the questions. So neutrinos are the fine particles which pass through your body a billions per second. So these particles are not interacting with any damn particle in the galaxy. So how you will detect them? They just pass through. They never interact. So we have a different way of detecting them under the ground. Now there are different telescopes, neutrino detectors. So we want people who will do this. Government is spending a lot and lots of billions of dollars. But then what is the outcome? We need, the data is lying there. You need to get the data, and you can get the data down here. The best example is when the Chandrayaan-2 smashed down on the moon, of the surface of the moon. There was a young amateur astronomer, or a young astronomer, I will say. I will not use the word amateur, because in astronomy there is nothing amateur or professional. Okay, the amateurs are sometimes much better than professional. They have done lot of research and lot of discoveries. Most of the discoveries in astronomy are done by amateur astronomers. So there is nothing like amateur or professional here. Okay, so the person, his name is Venkateshan someone. So he went on to the lunar mapper. There is another spacecraft which is moving around the moon, which was launched by NASA, and he checked the coordinates. He found out the exact coordinates where probably a Chandrayaan has crashed, and he got the data from the lunar mapper. He analyzed the data. He got the tools downloaded. He studied those tools. He came out with his own flowchart. He came out with his own process chain. Okay, and then he discovered first time. Discovery is always first time. Okay, so he discovered the remains of Chandrayaan-2. ISRO also didn't do it. So this is the power today we have, and the power is computing. The power is technology. Okay, so you can do anything. You can do wonders. Gone those days that you have to go to the libraries, and then you will have massive books and magazines, and then you go on hunting, and you are like a ghost there in the library. The libraries are so large that you never see the other end. Have you gone to the TIFR basement library? You will not see the other end. So you don't have to do that. You can be at your home. Just have a fantastic coffee in front of you and a nice computer, high speed internet, and that's it. But they should have a burning desire to discover something. That's the only thing which is lacking today, it looks like. Okay, so this is the slide. So variety of observations can be done. Okay, I will launch the courses to all these slowly. Now there are radio observations, which are the massive dish antennas. So we have the largest telescope in the world, which is called GMRT, Giant Meter Wave Radio Telescope, which is near Pune in Khodan. There's a village called Khodan near Narayangao, Mansar, Junnar. And that telescope is the largest in the meter wavelength. And so there are many telescopes in the world who are observing in the radio wavelengths. Because a star emits into radio also. A star also emits light. A star also emits heat. What is heat? Heat is infrared. Okay, so our infrared telescopes get the heat. So we have X-rays, gamma rays, variety of entire electromagnetic spectrum. Okay, so there are telescopes who are downloading that information, and that information can be used to discover new things. And there are Sun, there is Jupiter, there is for the Sun we have an organization in Udaipur. We call it Udaipur Solar Observatory. You can browse Udaipur Solar Observatory, and you will get the whole details. SETI project, search for extraterrestrial intelligence. Now there is an interest to look for extraterrestrials, and that is also very interesting stuff. Sky observations is another very difficult task. Sky observation is another difficult task because you need to have a tremendous practice for it. And I have my experience with the most brilliant students of this country for around 10 years is that they lack in this. Okay, the reason is people are good on the table. Okay, you do calculations, you do computing, but when it comes to the practical things, oh, then you have to wake up early morning at 4 o'clock, you have to see certain transits, you have to see certain occultations, you have to do the measurements, you cannot sleep, then you have to sleep in the morning time, all those things. And so night observations, to be a specialist in night observations is very difficult. But this is a great challenge to take. There are a variety of constellations. There are many constellations are the group of stars. We have total 88 constellations, out of them 12 are zodiacal signs. And these constellations are all illusions. There is nothing like a constellation as such. It is an apparent view of the sky in the night. And so to know each one, to know the stars, to know the galaxies inside, so and to operate the telescopes is something really, really challenge. Lectures and slideshows. Now in talks, the most difficult thing is to answer the questions of the audience. Anyone can prepare the talk. Anyone can read the slides. Okay. But when it comes to question answers, then that is something really, really challenging, especially in the field of science and technology. So you have to really know the subject. So you have to understand the physics, mathematics, and geometry, which is the core of the whole thing, really well, not for the exams. Okay. For your own sake. And then only you can answer, you can just go to the public and answer, any question. So these are some of the things. Model making is something very, very important because we understand 3 dimensions very well because we are 3-dimensional animals. Okay. So we understand 3D. Our brain is designed for 3D work. You know why we see the perspective? When we are standing on the railway tracks, we see the railway tracks merging on the horizon, which we call as a vanishing point. Why that vanishing? Is there any vanishing point in reality? No. Is there any horizon in reality? No. So these are all the illusions the brain creates because of the perspective. And the perspective is basically driven, kind of a hard, etched kind of concepts in our brain, in our genes, basically in our DNA, so that we can survive on this 3-dimensional planet. And so these are some of the illusions. Perspective is all illusion. So these are all the illusions which you see. 1-point perspective, you have 2-point perspectives, you have multiple point perspectives, you see the setting sun red, you see the rising moon big, all these things are all illusions. And these illusions happen because we are 3-dimensional animals. And so to understand these concepts of the universe, which is 3-dimensional or maybe multidimensional, but let's not talk about it. Okay, so let us talk about it. Let's make it simple. So 3-dimensional. And so in 3 dimensions, you need to have a proper model to understand. And this model making can be very tricky because you need to understand concept really well.
Parag,
So there are
sorry
many
to
models
disturb.
which can be seen in variety of places, and you can make them. But this is, I'm going to take courses on this, but it will take time. Model making,
Parag, sorry to
workshops and
disturb.
exhibitions, as I said, at variety of research institutions, which I have done myself. I have done with NASA, I have done with ESA, and I have done with Caltech JPL for many. So this also is a possible thing. This also is very much possible.
Parag, can you
Writing
hear me?
articles and books, this itself is like you are becoming a writer. And so this is a different discipline altogether. Okay, so do you really want to be a writer? Oh, fantastic, amazing, amazing. So you have to start writing small articles, you have to start writing your blog, you have to express your ideas, then you have to start writing books if you can do, then you can write multiple books. So this is a completely different domain altogether to become a writer in science. And believe me, now tell me, you are there, something around how many, 60, 65 participants at the moment. Tell me, in the newspapers, you take English newspapers, you take Times of India, you take Indian Express, or you take whatever you like. Or you take Marathi newspapers like Sakal or Maharashtra Times or Lok Satta. How many science articles you see in 1 month? And you will say maybe no, nil, or maybe 1. This is the level of science in public in India. It is pathetic. Let me tell you blunt. You have called me for a talk, and I should not hide anything from you. So in India, it is a pathetic situation, not because we don't have money. Please, we have a lot of money. The challenge is the mindset. ज्याला मराठीमध्ये आपण मानसिकता म्हणतो, त्याचा मोठा प्रॉब्लेम आहे. It's the biggest problem. And so if I am not expecting any change from the seniors, who seniors means who are beyond 21, okay? In a way, senior means adults. But those who are young, you still change. And really change this situation, which is okay, which is not happening. So, which I'm talk about, okay? Later, as you progress, okay. So, Comet, such a beautiful organizations, International Comet Watch, ALPO, Association, other observations where you can report your observations, which are required. There are beautiful comets. Halley's comet was something like this. So there are beautiful comets you can see with their tails, and there is a theory that we human beings have, the life, the life, not human beings is at the top chain, final part of it, on the top frame. But the life which emerged, and now there is a theory which is called panspermia. Panspermia, I will give a talk sometime later, you can join me. Okay, so panspermia is a massive subject by itself. I conduct 3 days workshop only on panspermia, but I just mean one line. So panspermia means the sperms means basically the material which is required, which is an organic material, which is required for life, has come on this planet from abroad, from elsewhere in the galaxy. That's called panspermia. And these basically these what you say, the medium who carried it are one of the medium suspects is comets. So there is a big research to happen related to these. Eclipses are one of the most beautiful things, and a lot of computations can be done about eclipses. You can see very beautiful, the corona here of the sun, and these are some of the very beautiful eclipses. Total solar eclipse. This is a diamond ring, which is happening. This I watched. This is my photo. I took this photo from. I took this photo from Missouri, United States, in 2017 in Colombia. Basically, this was one of the best eclipses I have ever seen in my life. There are many beautiful eclipses, but this is fantastic. Planets is a big subject of research, and NASA, or as well as ISRO nowadays, has started doing planets. Moon is the first, and there will be many planets. Many missions on many planets will be launched. So we need planetary scientists, we need engineers, we need electronics people, we need mechanical engineers, we need spacecraft designers, we need rocket scientists. Everywhere there is a demand. You tell me where there is no demand. Okay, but we want good people. We want, what is good? Good means they know what they are talking. Okay, they know what they don't know. Those people are good people, and to earn that you need to do a real hard work. Forget about your syllabus, okay? Forget about these classes and these exams, and that is not it. Please, it's something else. Okay, so we need people. There is tremendous demand in this subject. Okay, this is a fantastic image of Saturn, which was taken by Voyager spacecraft. Now, believe me, this image is taken by Voyager spacecraft, which was launched in 1978. Processing power was not even 1/100th. Listen to me. Voyager spacecraft launched in 1978 by NASA, Voyager 1 and 2. The computing power was less than 100 times your mobile phone. So this is the image taken by such kind of instrument. Now here, the brains are important. Here the concepts are important. The foundation is important, not the technology. Sun is another amazing subject. What should I talk about sun? I don't have time to do that. But sun is a star which is closest to us. And there are so many things. There are prominences, there are faculae, there are flares, there is atomic nuclear reactions which are happening. And so everything we need to understand. We know very little. The sun and earth relationship, we don't know anything about it. Meteors and asteroids, this is one of the subjects of my interest. I am working in the field of asteroids, discovering asteroids, and there are a variety of things we can do. Variables and binary stars. There are many stars in the galaxy which change their brightness. And so these needs to be studied, because why they change the brightness, we don't know. Because there are a lot of stellar astrophysical reactions which happen inside, which are basically nuclear fusion reactions. And we don't know them. There are PP chains, there are PNP chains, there are proton, neutron, proton chains. There are a variety of chains which happen. And variety of astrophysical phenomena, who Chandrasekhar Subramaniam, the Nobel laureate, who is no more now, he was the head of the department of University of Chicago in astrophysics, who got Nobel Prize in one of his great research in the white dwarfs. In the white dwarfs, the stars after death, how a star dies and how it becomes a black hole. So he discovered a Chandrasekhar limit, for which he got Nobel Prize. So these are some of the things which I thought, I will just go on. This is a black hole, and you see the jet, you see the accretion disk here, and you see let me annotate it so that you can see it better. Now, so this is the accretion disk. So this is a black hole at the center. Okay, we don't know anything about the black hole. Okay, still I can talk about, say, 32 sessions on black hole, but I know I don't know anything about black hole, to be very honest. Because these are the things which we don't have any idea, because all the physics laws fail inside the black hole. So most of the things are based on our current physics, current mathematics. And this is a star which is being eaten by the black hole. You can see the star is eaten by the black hole. So after a few years, the star will not be there. These are some very, very high-end topics, exclusive topics in astrophysics, which one can take. Now, this is nova and supernova petrol. Nova and supernova petrol, where the star dies in supernova. Okay, so these are some of the very, very interesting events. Very interesting events, because they are very rare, and we don't know how a star dies and why it dies. Okay, so this is something very, very intriguing kind of a thing, which are happening in the in the sky. So supernova discoveries can be done. Nova discoveries can be done. Okay, so this is the death of a star. So how the star explodes. So this is a supernova explosion, which you see here, and this is just a single star which is exploding. And we, the human beings, the life, the solar system has born from such kind of previously generated dead stars. So we are actually the children of the dead stars. We are the stellar children. Okay, where see, what are we made up of? What are we made up of? So we are made up of 5 or 6 elements, which are major elements. What are they? One is hydrogen. One is nitrogen. Then third, carbon. Our DNA is carbon. 4. What is 4? Phosphorus. Okay, ammonia. Okay, so these are some of the elements which are really crucial for our life. From where they have come from? Where this? I'm wearing this ring. Where this gold has come from? This comes from supernova deaths, star deaths. And so supernova is something very important as far as understanding the birth of the elements in the galaxy. Okay, we know very, very little about these supernova explosions which are happening time in the sky. And then there are deep sky objects. Those are nebulae. See, this is the horse head. You see the shape like a horse head, and this is a nebula where you see the like a horse head, but it's just a name given. But this is basically a gas cloud. So see, every dot sun is we can fit a million Earths. So this is the gas cloud and the new planets. As perform. Okay, so Just a minute. I'm just going to the next slide. Yes. So this is one of the most beautiful image. These are all the nebulae which you can see here, and they're basically the gas clouds, and many of them they're all real photographs. Okay, there is no Photoshop used here. It's all real. So these are some of the dead stars. These are some of the young stars. These are the nebulae where new stars take birth, planets take birth, and exoplanets might take birth. So data reduction is another interesting stuff where you get this massive data and how you analyze it. So there are Space Telescope Science Institute or ESA or NASA or a variety of facilities where you can download the data and make the discoveries. So this is something, which I thought I should talk about. SETI is another project which is called Search for Extraterrestrial Intelligence. Now we don't know where there is life outside, and we have to, there are a lot of work is happening at the moment, and very scientific work is happening at the moment, and we need people who understand biology. We want to know whether there is life outside the universe, outside the Earth, I mean inside the universe, or anywhere in the solar system or in the planetary systems, or in the other stars having planets like exoplanets. And so how we will find that? So we need to understand the life itself. We don't know the life itself. So we don't know thermophiles. We know, there are files, there are fine bacteria. Now this COVID has come. Now this corona has come. But do you know the cousin of corona was there in India in 1937? So this is just a cousin who has mutated itself. So this is not new. These kind of pandemics have come many times in the history of human beings. So how they come, how they work, how the bacteria work. There are bacteria who can survive in the thermophiles, means the vents of the volcanoes. Now the temperature in the volcano is something like 1600 degrees. And there are thermophiles who are alive. There are radiophiles who can survive radiation. If you and me exposed, you know what happened to Hiroshima people? Don't see that because they're so, it is so ugly to see all those things. Okay, so but there are bacteria who survive. How? Who knows? So there are a variety of things which we have no idea about. And that is where you people come in to do the research. And last and not the least is the ancient astronomy. So ancient astronomy of India, or ancient astronomy of China, or ancient astronomy of Greece, or ancient astronomy of Mesopotamia, or ancient astronomy of Babylonia, or ancient astronomy of variety of other Chaldea, that is a big subject of research. And definitely people can get into that. These are quite an interesting stuff you can go about. So this is a telescope, in the observatory, a small observatory and a telescope, how it looks like. This dome opens and you can see the sky, and the dome rotates by itself so that you can feel, the stars, you can see the stars at different angles. And so this is what I thought I wanted to cover, and I will stop here because the time is something like 16:16. I think I have spent more time than what Abhijit has asked me to talk about. Okay, so there are some questions you have, and they are in front of me, and there are quite a lot of questions. Okay, so Abhijit, how much time I have?
And you can go for 15 minutes, Parag.
Abhijit, you can come live and just say
15 minutes. 15 minutes.
How much time I can have? 10 minutes, 15 minutes.
Parag,
I can't hear you, Abhijit.
Parag, are you unable to hear Abhijit?
I can't hear you.
Yeah, so Mr. Akala is saying that you can proceed for another 15 minutes.
Abhijit, I cannot hear you.
Parag,
Can you,
Prashant, I hope you can hear me.
or I have to give you a control, or what is it?
Parag, can you hear me?
Parag sir, you have 15 minutes.
Okay, or you can make a check. I can say, okay, 15 minutes. Okay.
Yeah, correct.
Okay. There is a question. Okay, 15 minutes. That's a rapid fire. That's a rapid fire round. Okay, the question is, thank you very much. Okay, that is fine. How to apply for admission to IUCAA? Okay, see, this is a question which is quite nice. And the answer to the question is, focus on your physics and mathematics and chemistry and biology. Okay, not from the school level. I mean, not from the textbook levels. Read a variety of books. If you are 9th standard, you take CBSE, NCERT, SSC, and any other books available, QET, QET or whatever, American. So get 5-6 books and study one topic out of it. So suppose you take magnetism, study magnetism from 6 books. Okay, so this way you will understand it really. And then you have to complete your BE or BTech or BE in first class. And then you have to do your MSc or MSc first class. And then there is an entrance exam you have to apply. I mean, they will definitely call you for entrance. And then you have to clear that entrance, and then there is an interview, and then you can join for PhD, and you complete your PhD and be an astronomer. Okay, which exams? See, the exam, IUCAA has their own exam. Okay, so IUCAA, ISER, IISc, IIA, Indian Institute of Astrophysics, IIA, ISER, okay, IUCAA, TIFR, So these have their own different exams, but the exams are of different, same standard. Okay, which is basically BE level or MSc level. You have to crack that. Okay, these are the views of scientifically true. There is a question from Sonappa. In an overpopulated country like India, people are not going to follow scientific procedure. They are more interested in adopted traditional way. Yes, yes. So Sonappa, you are very right, and that is where we are lacking. And this is what I am talking about, is about the mindset. You are very true, and this is the mindset which we are talking about. Okay, there is a nice question from Prajakti. Why we don't have any graduation degree in astronomy in India? That I don't know, I'm sorry. But yes, there is no graduation degree in India in astronomy. Maybe there are a couple of universities, or maybe 5-6 universities offering the BSc. But MSc level, yes, Mumbai University, there is a degree, and MSc Ferguson College also they have. But yes, I mean, I don't have an answer for this, but that's very true. Okay, let us know some few tools to develop local scientific model for student creativity. You can make models using a simple cardboard. Okay, just browse on internet a bit, and you will get a lot of small models. But you have to understand foundations of astronomy first. So you need some basic book on astronomy to understand the concepts by yourself. Then you will know how to make a model. Suppose I'm talking about a celestial sphere. I should know that what exactly is a celestial sphere, how the celestial sphere moves, how the right ascension declination moves, how the stars rise and set, how to measure the angles, and how you get that perspective from topocentric or geocentric or lunar centric or solar centric or galactic centric, whatever frame of reference you use. Okay, so you need to know that. So first try to understand the foundations of astronomy. Okay, do planets have their own sound? If yes, in the presence of vacuum, how we can listen to them? Yes, we cannot listen to them. We cannot listen to the sounds of planets because in the vacuum sound cannot pass. So we have to record the sound. When the spacecraft is on the planet, we record it, we send it by radio, and then we convert the radio signal back into sound signal. The same thing when I'm talking to you now on the internet. Okay, so I'm talking to you, my voice is getting converted into electrical signal. Electrical signal is getting converted into digital signal. Digital signal is getting converted into wireless. It is transmitted across the country. And then it is again at the other end, it is getting converted back from wireless to electrical to voice, I mean sound, audio. Okay. Okay. So we can claim on the information we have, this is Prashant's question, that the laws of physics remain constant throughout the universe. Yes. At least at the moment, all our experiments without fail. See, this is where the science comes. Thank you, Prashant, for asking this. Listen carefully. This is where science is critical. In science, if a single experiment fails, that law is not valid. So Einstein's relativity holds true because for last 100 years, people have done millions of experiments and not a single experiment, you understand? Not a single experiment has failed. This is the power of science. So we need, doing this work, we have realized that the laws of physics are constant, same everywhere. This is a different kind of symmetry in the universe. Okay, so there are certain cases where the laws fail, like black holes, but there are very, very exceptions, super exceptions. So there is symmetry breaking. I will not talk about symmetry breaking, that's a big subject, but symmetry breaking is something where the symmetry is not seen, where it should have been seen. For example, a matter and antimatter, or dark matter and matter, baryonic matter and dark matter. Dark matter is 97%, baryonic matter is 3%. Why? We don't know. This is where I want the youngsters to come into this field. This is what we want to know. This is what is the study of the universe. Okay, we know the universe, we know about the universe where we live, and we know the number of galaxies it houses. Is there a possibility of having multiple parallel universes? Oh, this is a question which I cannot answer. I mean, I will say yes or no, but it makes no sense because we have no observational and experimental evidence about multi-universe. Listen, we have, I am on the screen, I am on the camera, and I am saying this with full confidence. We have no evidence, we have no experimental observational evidence of multi-universe. So there might be fantastic theories, you know, as Feynman has said, beautiful theories like string theory, bubble universe, you know, all those things. But we have no clue. We have no experimental evidence, so no scientist will believe it. Thank you. Kaustubh, I have a few questions. Do planets have their own soul? Okay, that I have done. Fantastic. Then what is the next? Prashant, I have answered. Deepak, why all are not switching off their camera? Sorry for that. Okay. Any other questions? No, that's it. Finish. Okay. Tell us something about supernova. Supernova is a death of a star. This is the last question I'm answering because we are running out of time. 1 minute I have taken extra. I will take 1 more minute. Supernova is an explosion of a star. A star explodes, but not all the stars explode. Sun will not explode. Okay, sun has no power to explode. So you should have at least 1.5 times the mass of the sun. A star having more than 1.5 times the mass of the sun to explode is a supernova. So that is the final. That is the death of a star. After supernova, of course, there are certain things like black holes, or neutron stars, or pulsars. Okay, so those are the different avenues the star takes. But that is basically the star is dead. I mean, what is the death of a star? Basically, the nuclear fusion reaction stops. So that is the death of a star. So you have no more nuclear fusion. That's the death of a star. That's called supernova. And that's an amazing event. That's an amazing event. Okay,
Parag,
so
I think there are
questions,
more
my
questions
friends.
you can definitely take. One of them is,
So before I
do you have
stop,
any
I will
suggestions
just
for
say,
youngsters?
okay, which we have very few schools getting children. Okay, I do conduct sessions of age group. Yeah, I conduct sessions, Lakshya Energy. I conduct sessions for the age group of 12 onwards, and those courses will come soon. So I will let you know. If you can send me an email, I will put it in my, or I will ask Abhijit to send that, so that you will know the future programs like Science and You or a Mysterious Universe. And I come live on Zoom. And so I conduct those programs. So this is see what was happening is for 6 months, I generally, 6 months I'm abroad, 6 months I'm in India. But because of this thing, I'm in India and I'm getting more time to set up my studio for more like YouTube channel and all those things. So it is coming up. So just be tuned to me and also on my Facebook page. Where are the jobs available? Yes, this is a good question. The jobs are available, okay? But the jobs are available to the people who know their subject. Let me repeat for the youngsters. You take any damn subject, okay? And believe me, suppose you want to do photography, okay? You do the photography, okay? You don't do any damn thing. You do only photography, but you do it so best that National Geographic hires you. That is your responsibility. So I'm talking to the children the same way I talk to my daughter. My daughter is 21 now. So I told her that, my dear, you do whatever you want to do. I will never ever interfere. You do what you love. Okay? You do what you love, but then you should be number one in your field, in the world, in science, in technology, in art. There is no national boundary. Youngsters, please understand. There is no national boundary. Okay? So you have to be the best. You want to do Python programming? Do Python. But then in the interviews, you will get an interview call.
तुला मी फोनच लावून देतो.
NASA, ESA, JAXA, wherever you call. Okay? But then you must be able to solve any question coming related to Python programming. Okay? You are in. There is no dearth of jobs. Please understand. There is always dearth of jobs for the lazy people lazy students who do not want to rub their ass. I'm sorry to use these words, but this is what it is. Okay, so let me tell you a fact. So work 18 hours. I'm talking to students. Work 18 hours. Your parents are giving you food and shelter free. Okay, so work 18 hours. And this is what I have told my daughter. She's in the US at the moment. So I told her that she went to US after her 12th standard. I told her, I'm paying for you. Of course, she got scholarships and all, but still some part I'm paying. But it is your job. It is your topic. You have selected your topic. And then work hard and be on the top. So this is the last you very much, every one of you, ending my session. Please log on. The email is milkywaycitizens@gmail.com, and on my Facebook page is of course Parag Mahasni, and you can just join me, and a variety of programs I conduct for corporates like wireless and space, and a lot of things. So we will talk, we'll get connected. Thank you very much once again, and Abhijit, please take it over from me. Bye bye.
Thank you, Parag. Darvesh sir, can you hear me?
Yeah, Abhasab, I can hear you very well.
So can you please close the session?
Yeah, certainly. So, Parag, thank you very much for such a messages we passed on to them were excellent. First and foremost is they do not have the dearth of the jobs. It is up to them how to utilize the options available to them. And with this particular series, our objective is to let them know what are the options available for them to choose. And what we've seen from the last and today's discussion is far too many options are available. It is up to every individual to select what is their passion, work 18 hours, like Parag said, excel in their field so that they do not have to worry about their jobs. Not at all. Very well conveyed and very well driven message, Parag. Thank you very much. I'm not going to talk in terms of what Parag covered in his topic or in his subject. He has given various possibilities. If there are any questions, you can reach to us. We can direct the questions to Parag, or Parag has given his email ID. You can reach to all of them. So I would like to thank Parag. I would like to thank GSES, Mr. Samir Saxena, for collaborating with us today. And obviously this particular program cannot be successful without the users or without the end participants. So thank you very much for 82 participants. We had total of 82 people today. and we will continue with this series. So we are going to take few more sessions on this. Abasa, would you like to talk about the upcoming series and when do we have
Yeah,
that?
I think the next session is by Parag's wife only, Mrs. Prajakta Mahazani, and she will be talking about careers in management. So I have requested her to share with us a brief and the subject title. So maybe within a couple of days we will circulate that. And once again, thank you, Parag. Thank you everybody who participated today. Thank you, Samir. Thank you, Jatin, for your great support. And we'll sign off for the day. Thank you.